Welcome back. We are now going to get to our second video for this week when we're going to be talking about how atoms come together and form different types of bonds. And we're going to be starting with thinking about what happens when you change the number of electrons. So we covered this already. When an atom loses an electron or it gains an electron, that atom now becomes an ion. So an ion is an atom that has a charge because the number of protons doesn't equal the number of electrons. You're going to find out biology is all about terms. So of course we have specific vocabulary for a positively charged ion, that's a cation, and a negatively charged ion is an anion. And I don't know if this works for you, but I like cats, and so I think of cats positively. So a cation is positive. You can come up with your own little device to remember it, but you will need to be thinking about ways, how can I remember these terms? So an ion, example of chlorine. Chlorine has got 7 electrons in its valence shell. It needs just one more, and that's exactly what chlorine does. It gains that electron so that it then has one more electron than there are number of protons, which equals a net charge of -1. So a chlorine ion has a charge of -1. Sodium, on the other hand, has the single electron on its outer valence shell. That sodium atom says, I do not want that electron. I want to be nice and full like the noble gases. So sodium's going to get rid of that electron and it's going to fill its valence shell, which will mean total it's going to have only 10 electrons compared to those 11 protons, giving it a charge of +1. So we can think about what happens to the elements on the periodic table. Groups 1, 2, and 3, they all lose their outermost electrons, those valence electrons, to become like that, like the noble gases, and with their full valence shell filled with electrons. So group 7 doesn't lose its electrons. Group 7, fluorine and chlorine, they're almost full. They're so close to being full. They are going to gain an electron. They are going to become negative ions, and they're going to gain an extra electron. So we've got this video, instant replay, what's happening? An ionic bond. Sodium is giving up its electron and chlorine is taking that electron. And then we're seeing that positively charged sodium and that negatively charged chlorine become friends and form what we're going to find out in a moment is an ionic bond. So depending on the atoms, a chemical bonds might be ionic or covalent. And an ionic bond is formed, not surprisingly, between two ions, between ions of opposite charges, so an anion and a cation. I do love puns. Names bond, ionic bond, taken, not shared. I'll spare you reading this one, but goodness, I do love ion humor. So again, an ionic bond forms when you've got a positive ion and a negative ion that come together. And this is usually from one atom giving up its electron to another atom that is almost full, becoming a negative ion, and then forming that ionic bond. So we can think about these bonds and what's being formed. We can think about them at the at the shell model, which is often called the Bohr models or the Lewis dot diagram. So we'll do ourselves a little quiz. What is going to happen to each of these atoms? Are they going to react and think about what's going to happen? Thinking about the fact that all atoms are going to make themselves like those noble gases with full valence electrons. So hopefully you already answered these and you were thinking about what's going to happen to each of these electrons. So we have potassium. What's going to happen to that single valence electron? For sure, it's going to be lost, and that's going to become a positive ion with one fewer electron, and that's a cation. Right here we can see sulfur is going to gain 2 electrons. It's 2 electrons short of that octet. It's going to gain those 2 electrons to become a -2 anion. -2 because of 2 more electrons. Aluminum is going to lose all 3 of its valence shell electrons. Losing 3 negatives makes it a +3 cation. And lastly, fluorine will also gain that 1 electron, filling its octate, filling its outer shell to become a -1 total charge, which of course would be negative an anion. So we had ionic bonds, and then we have covalent bonds. So what we can see here, this is not the same as an ionic bond. An ionic bond, one atom gives an electron, the other atom takes the electron. Here we see so much kinder. We see sharing of electrons. So that sharing of an electron is a covalent bond. They're not giving and taking, they're sharing. So chemical bonds are like toddlers with toys. Electrons can be taken or they can be shared. Taken and given, ionic. Shared is covalent. So again, here we have this demonstration. So this is how we can draw in the Bohr diagram or the shell diagram how these atoms are sharing these electrons. So that in this case, it's hydrogen with 1 proton and 1 electron. And they're both being shared so that both of these atoms have full valence electron shells. That first shell, of course, can only hold 2 electrons. For this next example down here, we see oxygen. Oxygen with 8 protons and 8 electrons, which means there's going to be 6 valence shell electrons, leaving space for 2 more electrons needed to fill up that octet. So oxygen is going to do that with each atom of oxygen sharing 2 of its electrons for 2 pairs or 4 total electrons being shared, and this would be talked of as a double bond. So this is covalent and sharing of electrons. There's different ways we can show this. We can have a molecular formula where we just count how many atoms of each different element there are. We can draw a structural formula where we draw it out with a line representing that covalent bond. We can do a Lewis dot diagram showing those electrons, and we can again show double bonds with 2 lines going through. So you can also, hopefully you watched this on your own, showing the differences between a ionic and a covalent bond. It looks like it's not working for me all of a sudden, but please let me know if it worked for you or if it didn't work for you, if there ever are issues that you're seeing. Here, we've got molecules. Molecules are when you have at least 2 atoms that are joined by covalent bonds. So they're sharing electrons. So something can be a molecule, or if those 2 atoms are different atoms, that's going to be a compound. So a compound has more than 1 element being shared by those covalent bonds. And here's that good remembering again, different ways we can demonstrate, we can refer to a molecule either with the structural formula, the structural model using balls, or that shell model. Okay, so here we've got a slide that's a little bit of a quiz where we can see can you identify what these different molecules and compounds based here? I'm giving you the molecular formula. Can you use that information to figure out which of these structural models? They're not quite structural models because they're overlapping a little bit, but you get the picture. So can you identify water and salt and potassium sulfide? Excuse me, sulfate. So hopefully here you understood why is this not a compound? It is not a compound because these are the same atom. So a compound has to be 2 different atoms. Hopefully you were able to identify sodium chloride right here. We have 2 different atoms being held together by an ionic bond. This one is H2O because we have 1 oxygen atom and 2 hydrogen atoms. And right here, this one would be potassium sulfate, where we've got 1 sulfur, 2 potassium, and 4 oxygen. So you need to be able to go between the different types of a molecular formula to think about a structural model and such. So again, doing a bit of review for these chemical bonds. We can think about looking at the periodic table, and the periodic table tells us everything we need to know about that element. In the fact that we've got in this first column, all of those elements are going to have one electron on their outermost shell, and they're going to want to give that up so that they can become more similar to those noble gases. Groups 2 and 3, it's pretty much the same. They're going to give up their outermost shells, but by the time you get to the atoms that have 4 electrons, they are going to share, and they're going to all need to share 4 electrons to fill up their shells. As we move forward, we can see the same thing. In row 5, they're going to need to share 3 electrons. Row 6, they're going to need to share and get 2 more electrons. And group 7, they will share or more likely take, and form ionic bonds to fill up that last missing electron. So just by looking at the number of electrons in the shell diagram, or looking at where an element is in the periodic table, we can see what kind of bonds and how many bonds will be formed. So for hydrogen, hydrogen's got 1 electron in its outermost shell. What's the max number of bonds that can be formed? 1. 1 because there's spot for 1 more electron. Hydrogen can only form 1 bond. Oxygen similarly, here we can see there's room for 2 more electrons. It can form 2 more bonds. Carbon can form 4 bonds. And this is why, in fact, you're going to always see carbon is going to have 4 lines coming out of it, because it always needs to have that valence shell filled. And lastly, nitrogen here, nitrogen you're going to see is always going to have 3 lines coming out of it, because it's going to form 3 bonds to fill up that valence electron shell. So last big topic, thinking about how we're sharing things. So we think about covalent bonds as they're being shared of electrons. But just like we remember with kids, things don't always get shared evenly. Okay, so when we have an even distribution of charge, that's called nonpolar. And that's when the 2 atoms in the covalent bond are equally sharing that electron. They're sharing it even halfway through. Polar is that uneven distribution of charge. That's when one atom is pulling tighter that electron, and instead of that toy being evenly split between the 2 of them, that electron spends more time by that stronger atom. So the most famous, or the most important for life's sake, polar molecule is water, where water is made up of 2 polar covalent bonds. That oxygen and hydrogen are bond between what we call a polar covalent bond. What does that mean? It means that electron is pulling those electrons to spend more time closer to the nucleus of that oxygen atom rather than those hydrogen atoms. And if I like to think of it as kind of like oxygen's the big meanie, and it's got strong 8 protons pulling those electrons closer to it. So we can think about it. We have another picture of here. We've got, again, this water molecule. And it's a molecule, of course, because it's covalently bond, meaning they're sharing those electrons unevenly with 2 different elements. And the reason why is because oxygen is very electronegative. It is pulling those electrons closer. So we see this little d, or this delta, this lowercase delta symbol. That's what means partial covalent, or partial charge that's formed in those polar covalent bonds. So this is slightly negative. These are slightly positive. And what's going to happen when water molecules connect with each other? The fact that there's polar covalent bonds linking the hydrogen and oxygen is going to result in what we call a hydrogen bond. So a hydrogen bond is the weak charge that forms between 2 polar molecules. So polar covalent bond between hydrogen and oxygen, hydrogen bond between that slightly positive hydrogen and that slightly negative oxygen. So hydrogen bond is between water molecules, where those polar covalent bonds are within a water molecule, holding a single water molecule together. But of course, hydrogen bonds aren't just between water molecules, they're between any polar molecule. So any slightly positive is going to be attracted to a slight negative. And even though this is just a slight, tiny little feeling, just like if your brother pokes you in the arm in one spot, one little thing done 1,000 times can add up and be quite powerful. So again, these partial charges occur when hydrogen atom is covalently bottom to a very electronegative atom. So the ones that are going to really be coming up in this class are number 1, oxygen, but also nitrogen, fluorine, and chlorine. Molecules that don't form polar covalent bonds form non-polar bonds. And these are usually, we're going to think about for biology as the hydrocarbons. So these are carbons linked together filled with hydrogens. Carbon you can think of as the nicest guy on the block. He or she is always sharing their electrons and is always sharing them evenly. So there's no charge, no slight positives, no slight negatives, no delta symbols here. Everything is nonpolar. So you wanted to be able to think about the characteristics of these different bonds and which ones are stronger. So covalent bonds are the strongest. Then we've got ionic bonds, which will break apart in water. And it's these little small bonds can make a big impact. So now here's your practice. If you cannot answer this question on your own, you need to go back and do more tests, more trials, more practice. So my first recommendation would be to do those lab practicums that are optional with Labster. But so you needed to be able to identify the atom, and so you wanted to do that by thinking about how many covalent bonds are being formed. And you can think about a covalent bond as these lines. So how many lines are going to come out of an atom are going to depend on how many valence electrons they are. And then I wanted you to think about how is a water molecule going to move and interact with that atom. And it's all going to have to do with partial charges. So the first thing to do was to identify what atom is what. These molecules have 4 lines coming out of them. Those atoms are going to be carbon. Next, we've got oxygen with 2 covalent bonds. That is going to be oxygen with 3 covalent bonds, needing 3 electrons to fill its outermost shell would be nitrogen. And then all those white balls with just a single line coming out of them are going to be hydrogens. And then we needed to ask what is going to have a partial charge. So again, that's that squiggly D. Oxygen is extremely electronegative. It's going to be partially negative. Nitrogen is extremely electronegative. It's going to have a negative slight charge as well. Why? Because it's going to be pulling the single electron from hydrogen closer, so it's spending more time with that oxygen. Those hydrogen electrons are going to go around hydrogen once and go around nitrogen a whole bunch more. So the hydrogens are going to be slightly positive, whereas the nitrogen and the oxygen are going to be slightly negative. So how is that going to affect water? That's going to mean that the slightly negative oxygen in water is going to be attracted to those hydrogens, and the slightly positive hydrogens are going to be attracted to that slightly negative nitrogen. And then finishing up this section, we were just introduced to chemical reactions, to the term reactants, what goes in, and products, what's coming out. And then lastly, we were introduced to what we will definitely be coming back to, but it's the idea of redox reactions. And these are reactions in which electrons are being transferred. So electrons are being gained or lost. And we've got specific terms for this. We've got oxidation and reduction. Oxidation is the loss of electrons. Reduction is the gaining of electrons. And just like in anything, if something is given up, somebody else gets it. So the thing doesn't get just disappeared. So if one thing is oxidized, the other atom is going to be reduced. And there's the mnemonic device oil rig, or my favorite is Leo and Gur. So loss of an electron is oxidation, gain of an electron is reduction. And we're going to see a lot of biology depends on where electrons are moving. And that is part 2 done.